Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called average of labels in binary tree. We have been given a non-empty binary tree and we need to return the average value of the nodes on each label, right? Alright, so this is the first example. The given constraint is the range of nodes value will be in the range of 32-bit signed integer. Alright, so let's try to understand this problem from the whiteboard. So at the first label, so these are all the labels, right? This is first label, this is second label, this is third label, right? So let's say first label, second label, third label. So we need to return 3, and because 3 is only the single value. At the second label we are having 9 plus 20, and by we will be dividing by 2 because we are calculating the average here, right? And at third level 15 plus 7 divided by 2, so this would be our output. This would be 3, this would be 29 divided by 2, 14.5, this would be 22 divided by 2, so this would be 11. So this would be our output. All right, now let's say hypothetically we are having here 9 is also having 1 or 2 node, right? Then what we will do, 1 plus 2 and 15 plus 7 and divided by 4 because we are calculating the average. Okay, so one thing is clear in this question, that we are going level by level. We are traversing like first level, then second level, then third level, and so on till n level, right? So definitely if we are going to the level by level, then it is a breadth first search. It's best suited for the breadth first search strategy. Why it is the breadth first search traversal? Because in the breadth first search what we do, we start with one node, then we check the neighbors, or here the children in this case, and then we will go to the second level, and then we will do the further children. So in binary tree terminology, we say it is a label order traversal as well. Okay, so let's do this. Let's try to understand what we are going to do here. So if we will take some kind of queue here, right? So initially in the queue we will have 3, right? So we will store 3 in the queue, and then we will poll this 3 from the queue, and the size is 1, right? So we will keep a track of size, queue size as well. So queue size is 1, and then our output would be 3 comma 3 divided by 1, right? Now after polling the 3, we will be inserting 9 and 20 to the queue, right? So let's go ahead and do that. Once we inserted 9 and 20, then this is the queue size is 2, right? And this is the second label. So now the size is 2. Now we will be polling basically 9 and 20, and we will add this, right? So 9 plus 20, that is 29, and the size is 2, right? So size has become 2, and then we will do 29 divided by 2, 14.5. So the second answer in our output array would be 14.5. So first will be 3 divided by 1, that is equal to 3, and then another will be 14.5. And once we will poll 9 and 20, we will say, okay, what is the children for 9? There is nothing, right? Null. So for what is the children for 20? 15 and comma 7. So after polling from the queue, we are inserting left and right child as well. So we did like 15 comma 7. Now size, queue size is again 2, so we will do 15 plus 7 and then divided by 2, so it is 11. So we will collect this output as well. So this is the approach. Let's convert this approach into the code, and once we will write code, I think it will be a little bit more clear, right? So let's go ahead and take here this result array. Let's say this is result linked list. Okay, so if it is non-empty binary tree, I'm not going to check any base condition for root equal to null because it's non-empty, right? So it will always be having some value. All right, now let's take the data structure called queue here. So node queue new linked list, and then let's go ahead and add root to this queue, and let's check while queue is not empty. I hope the intuition is clear for the breadth first search, right? So now here we'll be checking the queue size. So this is the size. We will be going until size I is less than size I plus plus. Now we will be polling from queue. So I'm not doing anything special here. This is just the breadth first search template that I'm applying here. So once this is there, then we can take additional variable here, that is sum, right? And let's define it as a double, because the result is double, so then we can take as a sum as well as a double. And then here what we can do, we can do sum plus equals to node dot val. All right, now let's check if node dot left is not equal to null, then insert node dot left to the queue. If node dot right is not equal to null, then let's go ahead and insert node dot right to the queue. So node dot right. All right, so now we are almost done here, right? Once this is done, then what we can do, we can do result. Oops, lot of typos here, so I'm correcting those typo as well. Sum upon size, that's it, and then we can return result here. All right, so that's pretty much it. So it's fairly straightforward label order traversal. We are taking the queue, we are inserting the root to the queue, we are checking while queue is not empty, we are checking the size of queue. Whatever the size of the queue, that's the number that we are processing, and that will be the size of that particular label, right? So here the size will be 2, queue size will be 2, here the queue size will be 2, here the queue size will be 1, right? And that's what exactly the number we need to divide. So it will be 3 upon 1, it will be 29 upon 2, and this will be 22 divided by 2 for this label, right? That's what exactly we are doing. We are accumulating the size sum. Here we are accumulating the sum of these nodes for that particular label, and once we are processing this for this particular size, then we are basically dividing that sum divided by size, and that will be the our output. So we are adding that to the result array. So let's go ahead and try to compile, and let's see if there is any error. If there is not any, then we can jump to the complexity part. So time complexity would be the order of n, and space complexity would also be the order of n number of nodes. Why? Because in the queue we end up going each and every node, right, to calculate the average. And space also, queue is taking the storage of all the nodes, so it will be order of n again. Let's go ahead and try to submit this. So looks like this is working fine. So that was pretty much it. Very quick summary before ending this. This is the average of labels in binary tree, right? Wherever we see the labels, or like the neighbors, or wherever this kind of the approach, right? So every label we are going through, right? So it is little intuitive to work from the breadth first search or label order traversal, because specifically it's saying the average of labels, right? So we can intuitively we can think of, okay, if we are going to the label by label, then it means we 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 don't need to, I mean, it's convenient to use the label order traversal rather than depth first search strategy, right? So that is the intuition here, and that is already been given in the problem itself. So we can go each level here, first level, second level, and third level, and then we can try to accumulate the size sum here, and we can divide the size here. So average is basically x plus y. The average of x plus y will be divided by 2. This will be the average, right? If we are having three numbers, x plus y plus z, then we have to divide it by 3. So whatever the number of these items, that we need to divide, and here that represents the queue size. So we are using the queue size here for each label. So I hope it makes sense. Thanks a lot. Have a good one. Bye.